Hi, everyone. Thanks for showing up for your learning. This says I've been away, and that couldn't be further from the yeah, that's really close to the truth, actually. So today we're going to look at factoring of really funky quadratics, and I'm going to show you two methods. First of all, it really helps to know how to build these for yourself so that you can always generate problems for your friends to practice and to know where they come from. Let's say I have these two binomials and I multiply them together. That would give me 10x squared from the 2x times 5x plus 4x minus 15x minus 6. And then I collect like terms. So I have 10x squared minus 11x minus 6. And this is the type of problem we might say, okay, we have some quadratic function f of x, and we're interested in finding its roots. We're interested in finding where it crosses the x-axis. All right, so if that's what we're interested in, I'm going to show you two methods of how you can express this in factored form. Just recall, our two forms of quadratics look like this. Ax squared plus bx plus c is standard form, so this would be f of x equals that. And then we can also have f of x equals a multiplied by x minus r and multiplied by x minus s. This is factored form where r 0 and s 0 are the roots or the x-intercepts or the zeros of the quadratic. Lots of synonyms there. So the first method that I'll show you is the logic and puzzle-like way of solving these. First, what we do is we're going to say this 11x, wouldn't that be nice if we could break that up into, well, in this case it's 4 and 15, but we don't know that yet. Okay, and we want to break that middle term up, and we're going to use an x game to help us do that. So I prepare my x game like this. I'm going to take this number b here, and these numbers a and c. I'm going to multiply a times c on the top. So that's 10 times negative 6, so negative 60. And then down here I use number b, so negative 11. And I'm looking for numbers that multiply to negative 60 and add to negative 11. 15 times 4. Okay, I found them. 15 times 4 is 60, and the difference of 15 and 4 is 11. So I have negative 15 here. I know that the 15 is negative because they add together to give me a negative number. And then the 4 there is positive. All right, cool. So now what I can do is I can rewrite this quadratic. F of x is equal to 10x squared minus 6 is going to be over here. But in the middle, from this x game, I'm going to use these two. Minus 15x plus 4x minus 6. I just took this negative 11 and split it up. All right? Follow me so far? That's the trick. And then I common factor this piece and that piece separately. Watch this. F of x, this is some function of x, as here I notice that 5x is the biggest common factor there. And that will give me 2x minus 3. Okay, so now you just check quickly your work and see that if I were to do 5x times 2x, I'd get 10x squared. And 5x times minus 3, I'd get minus 15x. So that's equivalent. All right? And you just want to always be checking your work that way. It means you're getting more math practice as you go. And you're also going to make fewer mistakes if you have this habit. And then I'm going to factor this one here. And I see, well, 2 is the biggest thing that can come out. So positive 2 multiplied by 2x minus 3. It's almost as if by magic the same factor appeared twice. So now that whole bracket can be factored out of each expression. And then we will have our thing in somewhat close to standard factored form. This would be 5x plus 2 multiplied by 2x minus 3. The 2x minus 3 factored out. Let's see, what do we start with? 2x minus 3 times 5x plus 2. Hooray! So we got the same thing back again. And then to put this into proper factored form, so I can really see the roots clearly, I need to factor out all of those coefficients of x stubbornly. I'm going to stubbornly take them out of each one. So this would be f of x is equal to 5 times x plus 2 over 5. That's dividing this whole bracket by 5. And then this one is going to be multiplied by 2 times x minus 3 over 2. Okay, that's factoring that one out there. And then I will have f of x is equal to multiply 5 times 2, 10, multiplied by x plus 2 over 5 times x minus 3 over 2. This is proper factored form, and it tells me the roots. The roots are negative 2 over 5 because these are sign flippers. Remember that we have to flip the sign because it's x minus the root up there. All right? So the roots here are x is equal to negative 2 over 5. That would make this one 0. Or x is equal to 3 over 2. That would make that bracket 0. So those are the two roots, finding them by factoring. But we can also express things in factored form using the quadratic formula, and that's what I'm going to show you right now. It's less parlor tricky, it's much more plug and chug, and it gets you to the answer when the numbers are big and scary. These numbers are not big and scary, but make them much bigger, and they get there pretty quick. So you want to have this method as well. Recall that if I know that 0 equals ax squared plus bx plus c, 0 equals that, okay? Then the quadratic formula is given by the jingle, and I'll give you the jingle here. X is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. And sing that every time and you won't forget. And you will also dampen slowly your fear of public humiliation, which is right gone for me. Okay, maybe not true. Okay, so anyway, here x is equal to negative b. So I'm looking at this line here to get my b, and my b is negative 11. So that is going to be positive 11, because negative 11 is positive 11, plus or minus the square root of b squared. So negative 11 squared, I'm just going to write down 121 because my squares are really good, and I happen to know 11 squared is 121. Came up in the last problem we just did. Very cool. Minus 4ac, let's write that out. Minus 4 times a is 10. See, I get that here. A is 10. And then c is over here, negative 6. Cool. All right, all over 2a. So 2 times 10. Yeah, I could have written down 20 and skipped a step, but I'm going to do a few lines here anyway. All right, x is equal to 11 plus or minus the square root of 121. Minus 4 times 10 is minus 40. Minus 40 times minus 6. 4 times 6 is 24. So this is positive 240. Check your calculator if you don't trust me. All right, so 240 there. And then divided by 2 times 10. So divided by 20. Okay? X is now equal to 11 plus or minus the square root of 361 over 20. The square root of 361. Whatever might that be? And you could calculate this, or you could use a calculator. Oh, it's 19 times itself.
Good morning, CCI. It's Hal and Mar, and these are your morning announcements. We begin the day letting you know that there are still yearbooks left over from last year. You can purchase a book through School Cash Online, and books can be picked up in room 1.
All right, let's carry on. So now we're very, very close, people. We're very, very close. Notice that I have x is equal to 11 plus or minus 19 over 20. So that means x is either equal to 11 plus 19, which is 30 over 20. 30 over 20, which is also equal to 3 over 2. 3 over 2, okay? Or 11 minus 19 is negative 8 over 20, which is also equal to negative 2 over 5, people. They're the same roots. Of course they are, because it's just two different two different tools telling us the roots. So now I just substitute that in. Y is equal to a x minus r times x minus s. And then I would have y is equal to a. How do I get that number? Well, you just read it, okay? There's a right there, tan. Okay, so put that 10 in there. Hello, Mr. Davio. And then just substitute in your roots. So we found one of the roots was 3 over 2. So put that in, x minus 3 over 2. And then the other one, x minus s, so minus minus 2 over 5. So x plus 2 over 5. And then notice that this line that we created with quadratic formula is the same as that line that we created by factoring. Two methods, one goal. Choose the one you like. I think you should know both methods because quadratic formula is going to work when the numbers are huge and ugly. Factoring is going to work to train your brain to reduce challenging questions to a pile of dust before you. Bye for now. Any questions, hit me up by email or come find me.